Composite functions can have some really strange properties sometimes. You can take two functions that seem in themselves quite okay and perfectly graphable, but when you put them together to make a composite function, they can end up sometimes sort of contradicting each other in a way that there is nothing that can, no values of x or y that can actually exist. Let's have a look at this one. Now, to work out what the composite function is, remember we just think, let's write down g of, not f of x, but actually throw in what f of x actually is here. And then on the next line, think, all right, now we need to write down g of x. This is g of x here, it's like a recipe for it. And when we write it down, all it's saying is take whatever you're finding the g of and throw it underneath the square root bracket. So we're finding the g of this, so we need to put all of it underneath the square root bracket like that. Now, this is now our composite function. And if we consider the domain and the range of this, we run into a few problems. Why? Well, because we need to just imagine putting in various values of x here and imagine what would happen. No matter what x is, whether it's positive or negative, and note that it's just the x that's being squared here, it's got a minus out the front. It's not minus x all squared, it's minus x squared. No matter what x squared is going to be positive. So we've got a negative sign sitting out at the front of a positive number. So we've got a negative number right there. And then we're taking one off that, it's going to be even more negative if it wasn't already. So this part in here is going to be a negative number. Now that's a problem because it's sitting inside a square root bracket and we can't take the square root of a negative number. So there is no answer that can sit over here, no matter what x is. So the first thing we notice is that the range has no values. Now when it has no values, we say it is an empty set. This set notation we'll come back to a lot more in year 12. At the moment we say things like the domain is all real x or the range is all real y. What we really mean is it's a set of numbers, all that are real, and we will get to calling things sets later, but to know it's just an empty set, there are no numbers in it. And similarly, if there is no range, then there can be no values either in the domain. We can try to graph this thing, but as soon as we put values in, we come up with an error and can't actually calculate it. So this means that the domain is also an empty set. Now this is going to make it impossible to graph this. It can't be graphed. There is no values that we can use to possibly come up with anything. So if we've got two empty sets, then we've basically got an empty function.